Morning, Professor and everyone. My name is Zhang Qian, and I'm responsible for the first part of our project introduction and data preparation. Our project is titled Online Retail Tool Statistic Analyze or Order Value. The data contains real online retail transaction recorders, including invoice number, product information, quantity, unit price, customer ID, invoice date, and country. We chose this date because it can help us study customers' purchase behaviors and explore factors related to order value. The main research question is what factors are associated with order value in online retail transactions. In this project, we focus on quantity, product variety, market type, and season. For my part, I focus on data preparation. The original data set contained 1,067,371 transaction rows. Since the rows data was at transaction 9 level, one invoice could appear several times if a customer bought multiple products. So, to avoid repeatedly completing the same order, I aggregate the data into order level, where each row represents one completed invoice or order. Before aggregation, I clean the raw data by removing record with missing customers' IDs and product descriptions, canceled invoicing, non-positive quantities, non-positive price, and duplicate records. After cleaning, we got 779,425 valid transaction 9 remaining. These were then aggregation into 36,969 order level records. I also create new variable for the group analyze. The main variable is order value, which represents the total value of each order. I also create a log order value because order value is right square weight, and the log transformation make it more suitable for ANOVA and linear regression. Other variables include total quantity, product variety, transaction line, average unit price, season, peak season, market type, and its overseas. So these variables help member 2 and member 3 continue with describe statistic, hypothesis testing, regression, and Monte Carlo simulation. In summary, my main contribution was to transform the raw online retail data into a clean order level dataset. This gives our group a consistent foundation for the rest of the statistic analysis. This is the end of my part. Thank you.
Hello everyone, my name is Xu Jing. I will present the exploratory data analysis and hypothesis testing. After the data was cleaned, our first step was to perform exploratory data analysis to better understand customer purchasing behavior before conducting statistic analysis. We analyzed the 36,969 order from the distributed statistic. We found that the original order value was highly right signal. The mean order value was about 470 points, when the standard deviation was 1,400 points. This indicates that the customer spending very greatly, with a small number of a very large purchase, increasing the averages. To make the data more suitable for statistic analysis, we applied a large transformation as shown in the histogram. The transformer order value become much more symmetric and approximately normal distribution. Next, we explore the relationship among the variables using different visualization. The scatter plots showing a positive relationship between product varieties and the other values indicates that customers who purchase a wider variety of products generally spend more. The board plot compares customer spending across the fall season. Although autumn and winter appear to have highly ordered value, we need a statistical test to determine whether their difference were significant. Therefore, we conduct a one-way ANOVA. Our null hypothesis that the mean large transformer's order value is the same across all fall seasons, when the alternative hypothesis stated that at least one seasonal mean is different. Before performing the ANOVA, we check the assumption using the Leavener test and the QQ plot. The assumption were reasonable satisfied, so the ANOVA was appreciated. The ANOVA result showing a statistical significant difference with a p-value below the 0.001. Therefore, we reject the null hypothesis and conduct that customer spending differs significantly across seasons. We then perform tricky HSD post-hoc test. We showing that the largest difference between the later season and the early season indicated stronger customer spending during the autumns and winters. In conclusion, our analysis showing that the seasonality has a significant impact on customer and purchasing behaviors, and the customer buy a greater variety of the product also tend to spend more. This finding provides useful insight for the retail when the planning inventories, promotion, and the seasonal marketing. This is conclude my presentation. I will now hand over to Juran for the linear regression and the Monte Carlo simulation. Thank you, everyone.
Thank you for explaining the EDA and ANOVA results. Now I will present the linear regression model, the Monte Carlo simulation, and the final conclusion. The purpose of this part is to identify the factors associated with online retail order value. Because the original order value was highly right-skewed, I used the log order value as the dependent variable. This transformation reduces the influence of very large orders and makes the regression model more suitable. The independent variables are log total quantity, product variety, average unit price, its overseas, and season. In the model, spring is used as the reference group for season. The model equation includes the effects of quantity, product variety, average unit price, overseas market type, season, and the error term. The regression model has an R-squared value of 0.7568. This means the model explains about 75.68% of the variation in log order value. The overall model is statistically significant with a p-value less than 0.001. The strongest positive predictor is log total quantity with a coefficient of 0.6987. This means orders with a higher total quantity usually have higher order values. Product variety is also positive and statistically significant. Its coefficient is 0.0031 with a p-value less than 0.001. This suggests that Orders containing more types of products tend to have slightly higher order values. Average unit price and overseas market type are also positive and significant predictors. For the season variables, the effects are smaller than the product-related variables. Summer is significantly lower than spring after controlling for other factors. Winter is not significantly different from spring. Although autumn had the highest average log order value in the NOVA, its regression effect becomes smaller after controlling for quantity, product variety, price, and market type. This means the higher autumn spending may be partly explained by product-related purchase behavior, not season alone. After regression, I conducted a multicolor simulation. The case statistic selected was the regression coefficient of product variety. I selected this statistic because product variety showed a positive relationship with order value in both EDA and regression. The simulation assumed a linear model with normally distributed residuals. I generated 1,000 simulated samples, each with the same sample size as the original dataset, which is 36,969 orders. For each simulated dataset, I refitted the same regression model and recorded the product variety coefficient. The observed coefficient is 0.003118. The mean simulated coefficient is 0.003119. The 95% simulation interval is from 0.002841 to 0.003376. Because the whole interval is positive, the positive effect of product variety is stable in the simulation. Overall, our study showed that order value is mainly associated with quantity, product variety, average unit price, and overseas market type. Season also has a statistically significant but relatively small effect. The multicolor simulation further supports the stability of the product variety coefficient. From a business perspective, retailers may increase order value by encouraging customers to purchase a wider variety of products. However, this study only includes valid completely orders and the data is observational. Therefore, the results show association rather than direct causation. This completes my presentation. Thank you for listening.